our first example with the law of sines will be angle side, remembering that that is just the given information and not a proof like in geometry. And as you can see by given information, you're seeing that you have, right here, you have an angle followed by a side. And so the first thing you do is you find the key ratio. And this is, again, just something that I talk to my students about to help them understand how the law of sines works, but also that this key ratio is what you will use in each calculation, or possibly you might have a slightly differing answer at the end. And SATs as well as AP courses require an accuracy to 3 decimal places, which is very sensitive to rounding errors. So by doing this, you won't make a rounding error. Key ratio is simple. You find a contained angle with a contained side. And that actually is all you need to know about how to use a law of sines. So some students will really stress out. Should I use law of cosines or should I use law of sines? Do I need to memorize as an angle side or side angle side? Or it doesn't matter. If you ever see an angle with the sides directly across from it, your key ratio is simply going to be 20, the side, divided by sine of 25. That's it. If you could ever get that ratio to come up, then you are good to go. You could also use the ratio sine of 25 degrees divided by 20. Is however you want to do it. I will do one example with the ratio this way and one with it that way. So this is the key ratio we can use. Just remember that if you use the first ratio, you're talking about having side on top and angle on the bottom. If you use the other ratio, you're talking about angle on top, side on the bottom. It doesn't really matter. So after you do that, after you set up that ratio, you're going to want to label your sides. So B is little b, that's the side across from 100. And then remember, if you just need to, you can always draw an arrow, right? And then side C would be from here. And of course, we've got to find side C by using the Angle Sum Theorem, which is a routine thing. And of course, you can label this A if you need to, but you've got your key ratio. So why don't we start by finding our angle C here. We're going to need it, so we might as well go ahead and find it. And the Angle Sum Theorem simply takes 180 degrees in a triangle and says, well, if you subtract out the other two sides, the two angles, forgive me. If you subtract out the other two angles, you will get the third angle, which in this case is, of course, just 45 degrees. Please use a calculator if you don't want to do that with mental math. Don't ever be afraid to use a calculator to not make a little tiny boo-boo. Because if you accidentally think that's 35 or something, it doesn't matter what the key ratio is. It won't be correct. So what you do is you take your key ratio, and in this example, you can see that I'm going to do the first one I have. The next example, I'll do this one, meaning the next example, the next video. So 20 sine 25 is going to be set up to equal B, right? Don't know B, but then divided by sine of the angle that's directly across from it. And C will be the same key ratio. And then I will do side C directly across from sine of 45 degrees. So how do we solve that? Well, the way you solve this is you just solve it like a normal algebra problem. You just reverse the order of operations. I'm trying to solve for B, so I'm going to multiply both sides by sine of 110 degrees, because if I multiply by sine of 110 degrees, it will cancel this, leaving me with B. Just don't forget to do it over here as well. Whatever you do to one side, you have to do to the other. Algebraic property of equality. Same thing over here, but notice that I just simply am going to be multiplying by sine of 45 degrees. So very easy to fix that, and same idea. It's just going to change what we solve it for. So over here, what we end up getting is we get B is equal to 20 sine 110 divided by sine of 25. And over here we get side C is 20 sine 45 divided by sine of 25. Those can simply be typed into a calculator. So just to remind you how to use a TI calculator, you would have to hit, in my opinion, you want to make sure the first thing is that you have it in the right mode. So make sure it's in degree mode. If yours is in radian mode, you would want to just click over to it and hit degree. On a Casio, there's a similar feature that you have to make sure it's in the right mode. So once you do that, you're going to hit alpha F1. You're going to go into fraction mode, N over D, and you can just type it in. 20 sine 110, and then you divide by sine of 25, and you can see that you'll get this answer, 44.470. And nice thing about the TI, you can go up and grab that, hit enter, and then just edit it. So you can go, just be careful how you edit it, right? I'm going to go right into here and put in 45, and then I can edit that to get the next side. Now for Desmos, which again, we're going to use quite frequently, and I feel like Desmos is going to continue to become a dominant force in math, you would want to type 20 sine of 110, making sure that it's also in degree mode and not radian. So the way it works is whatever it's showing is what it is. Think about how weird that answer is. Negative 0.88, it needs to be in degree mode. And then you highlight the whole thing and divide. It's an important step to do. Sine of 25. You can see I get the exact same answer. Or over here, all you'd have to do is you could just copy, Control-C, Control-V, or copy-paste. However you might do that if you're using a different type of operating system. You just edit that to 45. So you can see I get the exact same answer on the on the TI, on Desmos, and you would on a Casio as well. So now let's go ahead and just put everything together in our solving the angle. At the very beginning, there was a thing to fill out. So you can see what I've done here is I have taken the given information, the 25, the 110, and the 20 miles. I just wrote them down in their corresponding angle or side. And then for the 44.470, I got that from here. And the 33.43, I got that here. But notice I included the fact that they're miles. Obviously, when you calculate it, sometimes you lose those units. I also took my C, which I calculated from the Angle Sum Theorem, and wrote that in there. And this is what's known as solving a triangle, finding all sides and all angles. I like to have it organized by given and not given, just so you can see everything in the triangle in a nice place. Our next example, we're going to look at the next version, but I'll go ahead and use this other key ratio instead.